Greetings, space enthusiasts and curious minds alike. Welcome to our exploration of the cosmos. Today we're embarking on an exciting journey into the world of exoplanets. But what exactly are exoplanets? Simply put, they're planets that orbit stars outside our own solar system. Imagine our Earth spinning in its orbit around our sun. Now picture countless other Earths out there, revolving around their own suns in galaxies far, far away. Exoplanets are these distant worlds, and they come in all shapes and sizes, from gas giants larger than Jupiter to rocky planets smaller than Earth. The study of exoplanets opens up an entirely new frontier in our quest to understand the universe. It challenges our perceptions of what a planet can be and where life might exist. So join us as we delve into the cosmos, uncovering the mysteries of these distant planets. So gear up as we journey beyond our solar system in search of habitable worlds. You might wonder, how do we even find these distant worlds? Well, astronomers have developed ingenious methods to detect planets in distant solar systems. Let's take a closer look at two of the most common methods, the transit method and the radial velocity method. First up is the transit method. This technique is all about observing the light from a star and watching for a tiny dip in its brightness. This dip occurs when an exoplanet passes in front of its star, from our point of view, and blocks a small amount of the star's light. It's akin to watching a flea pass in front of a car's headlights from miles away. Now, the radial velocity method, on the other hand, is a little more complex. You see, as a planet orbits a star, it doesn't just sit there idly. It exerts a tiny gravitational pull on the star, causing the star to wobble slightly. This wobble affects the star's light, shifting it to longer, redder wavelengths as the star moves away from us, and to shorter, bluer wavelengths as it moves towards us. By observing these shifts, astronomers can deduce the presence of a planet. Of course, these methods are not without their challenges. The transit method, for instance, requires the exoplanet's orbit to be edge-on from our perspective, which isn't always the case. Similarly, the radial velocity method is more effective for larger planets that exert a stronger gravitational pull on their stars. Despite these challenges, these methods have proven incredibly successful. To date, they have helped us identify a plethora of exoplanets, from gas giants larger than Jupiter to rocky planets smaller than Earth. And with advancements in technology and techniques, we're getting better and better at finding these distant worlds. Using these methods, thousands of exoplanets have been discovered, and the count is still rising. So keep your eyes on the skies. Who knows what we'll discover next? Not too hot, not too cold, but just right. Welcome to the Goldilocks zone. The Goldilocks zone, also known as the habitable zone, is a term you might have heard tossed around in conversations about space exploration and the search for extraterrestrial life. But what does it actually mean? Well, imagine a region around a star where conditions are just right, not too hot, not too cold, for an Earth-like planet to maintain liquid water on its surface. That's the Goldilocks zone. It's a celestial sweet spot where temperatures are just right for life as we know it to potentially exist. Now, why is the Goldilocks zone so crucial in our search for habitable worlds? The answer lies in the magic ingredient of life: water. Liquid water is fundamental for life as we know it, and the Goldilocks zone is the area where a planet is just the right distance from its star for this life-giving liquid to exist. Too close to the star, and any water would evaporate away. Too far, and it would freeze into ice. But in the Goldilocks zone, it's just right. Of course, being in the Goldilocks zone doesn't guarantee that a planet is habitable. There are many other factors to consider, like the planet's atmosphere, its size, and its geological activity. But finding a planet in the Goldilocks zone is a promising first step in the search for life beyond our solar system. As we continue to explore the cosmos, we're discovering more and more exoplanets in their star's Goldilocks zone. Each one presents a new opportunity, a new chance to answer the question that has been haunting us for centuries. Are we alone in the universe? So next time you look up at the stars, remember that somewhere out there in the vast expanse of space, there might be a planet just like ours, nestled in the Goldilocks zone of its star, waiting to be discovered. Finding an exoplanet in the Goldilocks zone is like finding a needle in a cosmic haystack. Among the thousands of discovered exoplanets, some stand out more than others. These celestial bodies are not only notable for their unique characteristics but also for the profound questions they pose about the universe and our place within it. Let's start with Proxima Centauri b, the closest known exoplanet to our solar system. This rocky world orbits the star Proxima Centauri, which is only a mere 4.2 light-years away. The discovery of Proxima Centauri b in 2016 sparked renewed interest in interstellar travel, given its relative proximity. This exoplanet is roughly 1.3 times the size of Earth, and sits in the habitable zone of its star, where temperatures might just be right for liquid water to exist. Imagine, a world so close with the potential to harbor life as we know it. Next, we have Kepler-22b, a planet that was discovered by NASA's Kepler Space Telescope. Kepler-22b is located about 600 light-years away and is twice the size of Earth. It's the first planet that NASA's Kepler mission has confirmed to orbit in a star's habitable zone. Although we don't know if this planet is rocky, gaseous, or liquid, its discovery has further fueled our quest to find planets like our own. And let's not forget TRAPPIST-1, a system of 7 Earth-sized planets, 3 of which lie in the star's habitable zone. This system, named after the telescope that discovered it, lies about 40 light-years away, and has been a hot topic of research due to its potential for life. Each of these exoplanets holds a unique story, a piece of the cosmic puzzle that we are yearning to complete. They challenge our understanding of planetary formation and the conditions necessary for life. The more we learn about these distant worlds, the more we realize how diverse and astonishing the universe truly is. These fascinating worlds spark our curiosity and fuel our search for alien life. And who knows, one day we might just find that we're not alone in this vast cosmos. The universe is vast, and our search for habitable worlds is just the beginning. As we peer into the cosmic depths, the future of exoplanet exploration paints an exciting picture, one that's filled with boundless possibilities and new frontiers. The next generation of missions and technologies will undeniably propel us further into this grand adventure of discovery. Imagine for a moment the James Webb Space Telescope, set to supersede the Hubble Space Telescope. With its superior infrared capabilities, it will allow us to see through cosmic dust and gaze at the earliest galaxies. But its potential doesn't end there. It also holds the promise of revealing the chemical compositions of exoplanet atmospheres, giving us insights into their potential habitability. And then there's the Plato mission, short for Planetary Transits and Oscillations of Stars. This European Space Agency initiative aims to find and study a large number of exoplanets around bright stars, further broadening our understanding of these celestial bodies. But what about the far future? Well, there are ideas as fascinating as they are ambitious. Some scientists are envisioning gigantic solar sails which would use the pressure of sunlight itself to propel spacecraft to distant star systems. Others are contemplating the creation of self-replicating robotic spacecraft, capable of exploring vast swaths of the galaxy without human intervention. And what if we could harness the power of artificial intelligence? Machine learning algorithms could potentially analyze vast amounts of data, spotting patterns and making discoveries that might otherwise elude human observers. Beyond the exploration, the future might also hold the promise of colonization. Advances in technology could one day enable us to terraform and inhabit these distant worlds. Imagine stepping foot on a planet orbiting a distant star, gazing up at a sky filled with unfamiliar constellations. The possibilities are as boundless as the universe itself. The future of exoplanet exploration is not just about discovering new worlds, but also about understanding our place in the cosmos and redefining what it means to be a planet, a system, a galaxy. Who knows? Maybe one day, we might call one of these exoplanets our second home. Our journey beyond the stars has just begun. We've charted a course through the vast expanse of space, exploring exoplanets, those celestial bodies orbiting stars outside our solar system. We've unraveled the secrets of how we detect these distant worlds, using methods like transit photometry and radial velocity. We've ventured into the Goldilocks zone, where conditions are just right for life as we know it. We've paid homage to notable exoplanets that have sparked our curiosity and ignited our imagination. As we gaze into the future, we see a new era of exoplanet exploration, with advanced technologies and missions promising to reveal more about these intriguing worlds. But our voyage is far from over. Every star in the night sky could be a sun to another world, waiting to be discovered. Thank you for joining us on this cosmic journey. If you enjoyed this adventure, kindly subscribe to our channel for more exciting space explorations. Until next time, keep looking up.